So in part B, we want to find the instantaneous rate of change at several points. Okay, so why don't we take the derivative of cotangent of x. Okay, so y prime would be, I'm going to express tangent of x as, or cotangent of x as tangent of x to the power of -1. Then we can use the power rule combined with the chain rule to differentiate tangent of x. So this will be negative tangent of x to the power of -2 multiplied by the derivative of tangent of x, which is secant squared x. As such, I'm gonna algebraically manipulate this so that we have tangent minus to the power 2x. Okay, so let's apply the -2 there. That's gonna find the reciprocal, so it'll be 1 over tangent squared x times secant squared x. This will be negative tangent of x will be sine squared x divided by cos squared x, so that will be cos squared x divided by sine squared x, and secant squared x is 1 over cos squared x. The cos squared x cancel out. We are left with negative 1 over sine squared x, which is negative cosecant squared x as such. We can now evaluate the instantaneous rate of change at a few values here. Okay. So let's try it at one of these points here. Let's say pi over 3. Okay. Or let's use pi over 6. Okay. So y prime at pi over 6 will be negative cosecant squared at pi over 6. And sine of pi over 6 is equal to 1/2. So the cosecant of pi over 6 will be its reciprocal, or 2. So this will be 2 squared. Okay, and that should be -4. So pi over 6 is somewhere over here, right? So I'm going to draw that in red. Pi over 6. And the slope of the tangent to that curve is something that's negative, and it's quite steep, and its exact value is equal to -4. We can do the same thing for pi over 3. Let's find the instantaneous rate of change at pi over 3. And we're going to get cosecant squared pi over 3. Okay, and sine of pi over 3 will be √3 over 2. So this will be 2 √3. And we're going to be squaring that and putting a minus there, so we get -4 over 3, which is approximately -1.33-ish, repeating. And in red here at pi over 3 we do have a negative slope, and it's slightly less steep than the one that we saw at pi over 6, right? We saw that that was equal to -4. Okay, so there you have it. 2 instantaneous rate of changes to the curve cotangent of x.